delighted to be joined by Rendell Johnson, who's the co-founder at Smart Grid Options. Rendell spent 20 years in the kind of heavy industry space, infrastructure space, before founding Smart Grid Options a couple of years ago. So welcome, Rendell.
Thanks, Sean. Great to be here. I appreciate you having me on the podcast. Admittedly, it's my first podcast, so everybody's going to have to just bear with me.
Your first is always the best.
I hope so. Yeah, I hope so.
So obviously gave you a real high level overview, but do you want to give us a background into yourself, your career history, and obviously you moved into the fascinating world of data centers a couple of years ago. So do you want to give us a bit of a quick intro to yourself?
Absolutely, yeah. Started my career out of college in transportation as a civil engineer. And I quickly moved into rail transit. So when I got into rail transit, I got very interested in systems and traction power. So started doing a lot of traction power work, and I touched a bunch of substations. I saw the difficulty of connecting to the grid and pulling that much power from various locations across an entire city. And then after rail transit, moved into aviation, did some power work on some very large programs. And one in particular is kind of the origin story of our company. We had a very large power shortfall in a very large facility at a very big international airport in say it's in California. And they came to me and said, hey, what are we going to do here? So I knew my co-founder at the time, just personally, actually, our eldest children shared a nanny when they were very young. He's a great guy, and our wives knew each other, and he was an electrical engineer. And I knew he was super smart when it came to power and, kind of just being real scrappy with getting things done. I knew he had a lot of experience with large utilities. And so I called him up. We gave them a contract, his company, we brought him on. And through that process, we did kind of this large report. We solved the problem essentially. And through that process, we really discovered some of these great technologies that out there at the time for on-site power. Bloom Energy, Mainspring Energy. I think it's okay for me to mention their names. They're kind of out there, and they're not secret companies.
Yeah.
And we were very impressed with what the capabilities are for on-site power. And we were looking more and more into the data center power shortfall. And this was, kind of 3 years ago, not quite the problem that it is today. But at the time, it was becoming a problem. And we thought that this was a great kind of company to build around solving the power shortfall. Like, what can we do as a company together to kind of eliminate these bottlenecks that we see forming very quickly? And then we saw kind of the ramp up of CapEx investment, and just thought it was a great opportunity. And we had our big jobs, had our big companies, and here we are today.
Yeah, and just obviously, I know Smart Grid Options are trying to solve some of the power. Do you want to just give us a high level overview of the business as it is today?
Absolutely. It's we kind of have a multifaceted approach to helping data center customers get power. So we have an enablement division. We'll start with kind of getting their paperwork in order, helping them get gas if they want to do on-site generation, dealing with utilities to see if there's additional distribution or generation capacity in the grid, if that's an option. Mostly that's gone. That's pretty much all spoken for at the moment. Well, the generation capacity is. We'll get in later to kind of the distribution capacity and what we can do with that. But we get customers sort of aligned in their power plan and tell their power story. We help them with early generation procurement through various relationships with vendors and agents that are brokers that are kind of around the United States. And we help them build their data room, deal with tenants, some of the stuff all on the power side. And then after that is kind of our next step, where we have partnerships, and we have some exclusive partnerships with some very large manufacturers. We saw some very not easy to fix, but obvious bottlenecks in the equipment procurement space. So power transformers, dead tank breakers, medium voltage gear, low voltage gear, all of this stuff, dry type transformers, all of this stuff started to become more and more constrained, just as the same with the power generation equipment. Turbines are out till 2030, 2031. Medium speed engines are sold out. We have all of this generation equipment that's essentially impossible to get now. We're seeing the same kinds of things in some of the distribution equipment as well. And so we have partnered with our great manufacturers here in North America, specifically in the data center market, to bring larger capacity for all of this kind of missing gear, right? This bottleneck, power transformers, oil-filled dry types, medium voltage, skidded solutions, a lot of integrated solutions in the low voltage side we're working on. And again, we could talk about that a little bit later. So those are essentially the solutions that we've brought to the industry.
Yeah. And it's you'll have to open up LinkedIn on a daily basis, or the news, and power is probably the biggest constraint in the data center market currently. Everybody is wondering how they can get access to it, etc. So why do you think power has become kind of the biggest constraint in data center growth?
It's a good question. I'll give it a kind of a long answer. I'm not a historian, but we will go back to the building of the grid. Yeah, the building of the grid originally, it took a lot of federal investment. It was a really big challenge to build the grid. In the urban areas, it's pretty easy, right? The densely packed urban locations. There's a lot of financing that made sense there, right? Like, hey, we can build these short distribution runs and we can make money selling power to customers. But then when you leave the cities, there's the economic model just falls apart. And so, back in the 30s, 40s, 50s, it took all of these kind of very low interest federal incentives and federal loans to these rural co-ops. And they kind of built the backbone of the grid, just through a lot of union labor that was paid by these co-ops. Anyway, once that was built, we kind of had this structure that only grew with the population. It's the last 20 years pre-data center boom, it's been 0.5% growth, annually. And that kind of just, there wasn't a lot of sales of turbines, for instance. You didn't really need to build that many substations. You didn't need a bunch of network stations and even kind of ISs, these smaller distribution points. It's just like you upgrade as you need to, but it wasn't this massive need that then the data center market comes along. We see this massive CapEx investment, and now you roll back the clock 4 years, and if you're doing a 25 megawatt data center, that's a big data center. Like it's a lot of power. Yeah. Now it's like you're gigawatt or you're nothing.
Yeah, so exactly. I mean, the facilities have just exploded in terms of power and generation, haven't they?
Yeah. And so the utilities just weren't originally set up for that, going and saying, hey, I need 1 gigawatt of power. That's like, that's like a major city growing up out of the ground in an 18-month period. We're not built around that.
And like you said, even the facilities, they're built in most cases in rural areas. So like you said, historically, that's obviously, something that wasn't even in place. So we're kind of going back and rebuilding a grid, aren't we, in some aspects?
We really are, on the distribution side, for sure, because nobody's taking a gigawatt and putting it in the middle of New York City, right? Where you might have short infrastructure to build it. You could do it. You're in, rural Kansas. It takes a long time to get power out there. It's a big build.
Yeah, no. And I think obviously Yeah, that's obviously a really good analogy. I'm pleased you've gone into a lot of detail there because I don't think the industry actually understands why the power constraint is there. I think people in the industry do, right? But people, when they hear about it, when they're not involved in the industry, don't understand why they need so much power or why there is such a power shortage. But I think it makes perfect sense what you've said. So I suppose why is kind of like moving on to the next question, why do you feel like AI driven data center demand is different from kind of normal utility growth?
Yeah, that's a good question. Again, utility growth is usually increased with the population, right? You build some houses for people.
Yeah.
That's relatively low power stuff, and it kind of slowly grows as our population grows.
Yeah.
We haven't until recently seen a big influx of onshoring of manufacturing, and so kind of we transitioned to LED lighting, which kind of like lowered our power demand in some ways, right? We did see some EV charging, but then the EVs kind of like leveled off a little bit, right? Of say, I don't know, 4 years ago, and so that wasn't driving that much demand. And then the AI data centers come along, training centers in particular. It's a gigawatt. It's a massive power ask in a single location, and
Yeah.
we just haven't seen anything like that for ever really.
Yeah, and I think obviously there's there's so much demand for data centers across the US, Europe, etc., APAC. Would we're talking about a gigawatt now, and some we're talking 5, 7 gigawatts, and it seems scary, doesn't it, in rural areas? But how do you think, obviously, how do you think the market can catch up ultimately? Following on from that question, how do you feel like the grid can ultimately catch up? Is that just a sheer manpower thing from your aspect, or?
Yeah, hard work. I think
Yeah,
I think it's hard work. I think it's hard work not just out in the field, um, by all these great unions we have in the United States and all of these amazing contractors we have building out our data centers. I think it's also work in the factories. We have to we really do have to just drive more labor into manufacturing. That's my opinion. I think we just need, if we need more stuff, we need to make more stuff.
yeah,
And
yeah,
so I think it's a combination of leaning on international capacity and also kind of fostering our own domestic capacity. And there's a
yeah,
balance, right? I mean, there's a lot of it's kind of a politically charged issue to talk about China, right? And
yeah.
manufacturing in China, but to be honest, China just has some really amazing manufacturing capabilities, and we could utilize that, and while we could also grow our own domestic capabilities.
Well, yeah, I think the Western world is kind of manufacturing was probably it's strange because manufacturing construction were always sometimes seen as second rate careers and things like that. I think the great thing about the data center world is it's bringing them sort of careers back to being like get into construction, get into manufacturing, etc. Because we used to offshore that, or obviously not general labour and construction, but manufacture is typically offshore for cheaper labour and resource. But now, because it's in so much demand, everyone wants to bring it back onshore, don't they? And that's probably 40, 50 years of releasing it offshore. Now you want to bring it back. It's not just a simple quick fix overnight, is it?
Yeah, no, it's not. It takes a generation. We lost it in a
Yeah,
generation, and we're going to have to bring it back in a generation. It's
yeah,
a big ask. I mean, these factories are, um, we go to Shanghai, visit our partners all the time, and they have some very, very advanced networks. It's not just their factories. It's and the robots that are building all of their stuff. It's all the ecosystem around their factories that support the robots that build their stuff. They have this really dense vendor network
yeah,
and we just have to bring that back. I mean, we just have to build it here, and it's not going to be fast. but it's going to be a lot of fun. I mean, we're going to have a great time because
Yeah.
I think we're going to be the generation that rebuilds American manufacturing. And I think that's great.
Yeah, I think like I said, it has to happen ultimately because not going into political turmoil, but there's so many things that then affect the supply, the supply chain, don't they, and things like that if you don't have it here. So it makes a whole lot of sense. We touched on it, but obviously, love a founder and how things started. So how did kind of SGO's 55 megawatt power shortfall lead to the company's founding ultimately?
Yeah, it's a fun story. Again, it was my co-founder, Nick, was, again, maybe the smartest guy I've met. I've been lucky to partner with him because he really brings the brain power of our partnership up quite a bit, and he really increases the average. And it was a large facility that did not account for EV charging.
Right.
And they are going to be probably one of the biggest hubs of EV charging in the United States. And so when we dug into that problem, we again discovered Bloom Energy, Mainspring Energy, fuel cell energy, all these on-site power technologies. We were shying away from, and I'm not taking anything away from medium speed or fast speed gas engines or on-site gas engines. It was in California, and so we were kind of shying away from that as an option. I think they're great options. They're just not really great options in California if you're on a timeline.
Yeah,
that's just the way that the state permitting works. And we ended up solving the problem so my partner had these great political connections. We ended up solving the problem with some load management systems, which are, for large facilities, I highly recommend, especially if you're getting into different kind of, if you can push load around by time, right? And you can kind of eliminate those things like the big duck curves, right? And you can level that out across a 24-hour period. We had some of those fixes mixed with some very good, how do I put this? Kind of a political solution with the utility.
Yeah.
And just partnering with them, to be honest. And we didn't stop it, but we avoided the build of a 100 megawatt network station that would have cost us $150 million, taken 5-6 years. So we kind of really bought the facility some time. Not that they won't have to do something like that in a few years, but right now they're in a very good spot. And that's essentially how we. Again, I just saw the writing on the wall. I'm saying, listen, this is a great potential business. This can't be the only problem like it in the United States. And so we really put our heads together.
At that point, had you thought of the data center world, or when you started looking into the problems, that was obviously the number one power shortage demand? Is that what you found?
Yeah, my partner he's been in the data center world for over 20 years.
Yeah.
He's one of the best data center electrical engineers, in the country, I think. I don't run into people very often that know as much as he knows. He's very, very knowledgeable. And so he knew that this problem was coming. He had been talking about it to me at parties and coffee and so forth. And I kind of knew in the back of my mind, we should probably do something about this. We see it. We see kind of rack density and power density at the rack level increasing. So obviously we're going to have some sort of a problem sometime in the future. We didn't know it was going to be quite this big, to be honest, but he was already there in the data center market. And so when we kind of started our roadshow of, hey, we can solve your power problems, we started with some CNI customers, but quickly everything became data center. It was within 6 months, that was the only groups that we were pitching to were data centers.
Well, I think the great thing about the industry, there's so many great things about the industry, and it's a fascinating space to be in. Is the amount of new businesses that have been formed to solve, power's one, cooling's another, etc. Technology. So I think that it's given so many aspiring entrepreneurs and created so many fantastic businesses like your own through the market, and obviously you're helping the industry solve its biggest challenge. Small, big, whatever you say, you're obviously doing a great job. So long may it continue. I'm sure. So. Why do you think more developers are turning to on-site power and kind of BYOP strategies, bring your own power strategies? What's the reason?
I think it's necessity. I don't think at the core of a data center developer they want to own and operate a power plant.
Yeah,
I don't think that they would do that if they could get the power from the grid. But once you do it, I think that you can really see a lot of the advantages in just in the architecture of the data center itself, because essentially you're building the power plant and the data center at the same time, and there's a lot of opportunity to reduce capex investment. So I think they're turning to it because they can't get grid power, and I also think that there's a lot of on-site options here, and a lot of we see a lot of kind of technologies moving this direction that are really assisting them in developing these on-site power plants.
Yeah, so it's kind of you kind of saying that they've had to, because for one there isn't the option. So but secondly, in doing so, obviously they've uncovered that it's maybe cheaper spend, and they obviously got more fluidity in the architecture of the actual facility itself.
Yeah, we see kind of financing vehicles catching up. We see contractors are much more savvy with the installation. We see there's a lot of IPPs that are kind of building a business around this. 2 years ago, we had to sell an on-site power plant to a customer, and now they're selling it back to us. It's now we had a whole section of our intro deck, about grid reliability and gas versus gas reliability, gas availability, kind of all of these initial things that would kind of really set the stage for, hey, you can build your own power plant and it is very reliable. We scratched all that. It's not even necessary now. Everybody understands that it's there. It is the way of the near future, and it can be done.
Yeah, and it falls on to kind of, why do you feel like natural gas is the primary bridging fuel today?
Yeah, natural gas. So we have a lot of it. Number one, the United States is very good at making or pulling out natural gas.
Yeah.
It is the only dense energy source that is piped around the country. To pretty much every square inch of this country there's gas availability, and it's pretty clean. We can burn it clean. We can run it through a fuel cell. We can crack it and run it through a fuel cell clean. You can compress it like a linear generator clean. You can really reduce your particulate outputs and all your there's technologies out there with zero NOx and SOx emissions, no formaldehydes, anything like that. The only output, of course, is CO2, but that's kind of all. I don't say all, but most energy technologies right now is CO2 is going to be an output.
Yeah.
So, it's just a great. To be honest, it's a great fuel source, and it's available and it's abundant.
Do you think? Obviously, I know we try and talk about the future of data centers and stuff. Do you feel like anything is coming down the line that may change that?
Well, let's see. They're the data centers in space.
Yeah.
Probably niche to get started. I think the kind of the near, we'll say, I'm not going to predict the timeline because I don't really know, but it's going to be SMRs. It's going to be these small nuclear reactors that are going to sit on site.
Yeah. That's what I was referring to. Really, do you feel like nuclear kind of is going to be the kind of next thing we kind of see from a fuel gas perspective? Yeah.
I think minus the smaller things like better use of batteries and more reliable grid, reducing line loss, like kind of increasing the efficiency of the grid, which is kind of smaller. We can capture some kind of efficiencies there. I think the big fix is going to be one of two things, and it's either going to be nuclear, right, and kind of like a distributed nuclear generation network, or it could be solar. I mean, we don't do solar, that's not our thing, but it's with the right incentives and the right distribution and storage, solar could make a big dent. It really can. I mean, there's a lot of possibilities there. So it's one of the two or both.
Yeah, exactly. I think everyone's I think I've spoken to a lot of people talk about nuclear power. I don't hear as many people talk about solar, to be honest. But yeah, obviously that would be probably a cleaner way of doing things, wouldn't it? I'd imagine.
Yeah, I mean, look what China's doing in the last 24 months. I mean, they are just they're building gigawatts and gigawatts of solar to the point where it's free. It's they're buying it on the market for free, or almost free. So it can be quite abundant, and it can definitely make a dent in our power demands.
Yeah, amazing. And how are you, I suppose, from a business helping solve kind of transformer and electrical kind of equipment bottlenecks? Obviously, it's one of the other challenges I often see, manufacturing and stuff like that. How are you helping solve that as a business?
Yeah, so we just looked at capacity. So we looked around the industry. We see the bigs, and I'm not gonna throw any companies under the bus, but the big power transformers, in particular, dead tank breakers, all the substation build outs. And even kind of the larger medium voltage transformers, they were 2.5 years, 3 years backlogged because they just weren't prepared. Nobody saw this boom coming so quickly.
Yeah.
So my partner and I kind of I say we scoured the earth, but we did a lot of traveling, and we did a lot of touring and saw a lot of factories, and we looked for capacity essentially. And so we went out into the world, and we found some very high quality manufacturers with capacity, and capacity in that they had maybe a couple different ways. They had bought and were turning over other manufacturers' factories and repurposing them, building their own factories. One of our manufacturers a power transformer manufacturer has a brand new factory. It looks like a hospital. It's incredible. It's robotic, very nice. And they had just come online, and we just were introduced to them at the right time. We work extra shifts. There's opportunities where we can kind of run extra shifts at some of these factories and really increase capacity. So to answer the question in short, it's capacity. We found capacity, we partnered with that capacity, and now we're bringing that to the market to try to eliminate these long lead time issues.
Yeah, I mean, that's quite a humble answer. You've obviously amazing as a company since your inception, and obviously, yeah, you timed the market well. But like you said, I'm sure a lot of hard work, effort has gone in from you and your business partner, I'd imagine.
Yeah. And we have one of our partners lives in China. He's been very helpful. He's very well connected. But we have domestic partnerships as well that we lean on for specific types of gear that's just better to bring out of the United States again. But capacity is oftentimes the issue with domestic partnerships.
I think that's the thing, isn't it? Like, the facilities now that everyone wants to build them in the fastest time possible. That's how, it's kind of in some ways, the money is secondary to the speed, which is, difficult in most markets to kind of get your head around. But I find that faster you can do something, kind of, not saying the money's no object, because it always is, but I think a lot of facilities now are delayed because of the manufacturing difficulties. It's well publicized, isn't it? So if you're helping to solve that in some way, then it's that's a great place to be in, I suppose.
Yeah, we sometimes say our best customers are the ones that are in trouble with schedule.
That's like it's like to be fair, it's like most businesses, right? So like staffing works the same, right? We have it. The best customers are the ones in the most need because they're the most urgent. They need your services. So it's I think that's I'm not saying for every industry. I've not been involved in many, but I think that's always what happens. That you get them faster responses, quicker leads, etc. So I think yeah, it makes sense. Definitely in my world as well.
Yeah, yeah, we don't love people in trouble. I mean, we definitely want to get to them so we can all kind of do it in the right way and not under duress. But sometimes the schedule dictates, and we can definitely meet the call.
Yeah, well, it's obviously you then need to meet their demand of speed, don't you? Which if you can do that, then they win, you win, etc. So, why do you think kind of prefabricated electrical solutions are becoming so important?
Yeah, this is very exciting. Actually, I'm personally very excited about how we can kind of start building out a kit of parts for data center construction. So a great example of that is the low voltage integrated solutions, so skidded solutions.
Yeah.
Some very great opportunity to eliminate on-site labor. So right now you have gray space, electrical rooms, and you can only get so many electricians in there at one time. If you can even find the electricians that you need, again, they're highly sought after. These are very skilled laborers, not always easy to find an army of electricians, especially in some of these rural locations. And you can only put so many in a room at a time. And so the current, the older way was to kind of, you bring in your gear, you bring in your transformers, you bring in all your distribution, your UPS, your battery cabinets, and then you kind of just assemble everything on site and you wire everything together. So what we're doing is we're doing that at the factory. So we're it's metal frame, right? And everything is installed right at the factory. Everything, all of the wiring, bus bar, this is all like pre-assembled, pre-tested. So we're testing it on the factory floor, and we can line up hundreds of pieces of switchgear, 100 of these low voltage integrated solutions, test every component right in the factory under controlled conditions. So, and we can throw an army at it. We can throw as many technicians at that in the factory as we want. Whereas if you're on site doing that, it's much more difficult just because it's constrained by labor, but also by space.
Yeah, no, definitely, yeah.
And they're also much more dirty environments, in construction. There's could be earthwork happening outside, and so you're trying to keep things clean. So we do these in like controlled factory conditions, do full factory testing. Any components that need to be swapped out, well, we're sitting in the factory that makes them, so it's very easy to get everything right, perfect, ship it, you pack it, ship it, and then drop it on site in a single kind of Lego piece. And then we do site acceptance testing. We'll bring in temp power, turn it on, test everything, run through a testing checklist, and then that's it. It's
again though, it's sort of that you're saving time, isn't it? Saving time for businesses when time is crucial for them. Every day they can save, or every hour they can save, that's what they're looking to do. So if you can pre-package that up and have it as one solution, and it saves all the things that you were talking about, and obviously it's better for the industry ultimately.
Absolutely, yeah. Anything that can be prefabricated and pre-tested to meet the customer spec and delivered, I think is the way data centers should be built.
What that obviously that's coming, that's been rolled out. What are the not saying for your business, but what typically would you see as objections that are people worried about the testing phase and the commissioning side of that, or from that perspective?
We've seen a little customer reluctance on, I would say, like the shipping process when you do factory testing and then you have to put it on a truck and drive it halfway across the country.
Yeah.
What does that do? To the bolts loosened? Are the breakers okay? Like what happens to the batteries? I guess they're a little concerned about that. but we mitigate everything with site acceptance testing, with license, with licensed technicians, and we don't think it's a problem. But that's kind of the only thing that I've seen as being the issue. There is, I suppose, you're kind of locked in also. I mean, preferably you're working with a complete design that you're not changing on the fly, which sometimes happens. Because you have to build it before you ship it, and so you want to make sure all the specs are correct and you're building exactly what you need on site.
And that obviously requires somebody on site to give you the correct spec, which is So, and what trends are you kind of seeing in hyperscale kind of facilities in design and construction?
So we are seeing more and more of the prefabricated solutions being kind of looked at, being spec'd. We see a lot of customers shying away from water usage, so on the power gen side, cooling side, and also emissions, noise, things like that. Because I'm sure, as everybody listening to this podcast knows, we're running into some public pushback, in various parts of the country, and those things are kind of centered around 4 things as I see it. It's water usage, it's emissions and noise from on-site generation, and it's local traffic, which, again, back to the prefabricated solutions, you're driving in less trucks, you're driving in less people, you're commuting to the site less, and that's kind of a good impact to the local community. And then land use is I don't know how to solve that. That's beyond our scope.
Put them in space, but that's
you can put them in space. It's a big building to put in space.
Exactly. I'm only joking. I think there's obviously, like you said, there's community pushback but I think as well, for me and what I see, obviously I'm not technical. I don't claim to be technical. I've been in the industry a long time. I don't claim to be. I just think the wider public don't actually understand why they need a data center as well in their life day to day, like what it actually solves for them. Us having this conversation, logging into your mobile banking, do you know what I mean? Things like that is what, but people don't understand that. And then if that was all taken away, obviously, how would that happen? So I think as well, it's an education piece to the communities and people outside the industry of, yes, there's obviously, like anything, there are obviously going to be some drawbacks and things of a massive facility, but ultimately the benefits to society, economically and everything else, outweigh them. Obviously everyone's different, everyone has a different opinion, but that's I think a lot of people don't understand what a data center does until they're actually involved in the industry.
I don't want to get politically contentious. I don't know who's listening, but we have, I think, some of the messaging. I don't know how this happened, but early on, the messaging kind of came out as AI is going to take your jobs.
Yeah.
And that's the wrong message. I mean, there's a great article last week from the CEO of Goldman Sachs, and he basically said that's not how things work. That's not how the economy's ever worked. Industry changes and technology development has only created more jobs throughout human history. Why would this be any different? So I think the messaging somehow took a left turn at some point.
Yeah.
And again, I don't think a lot of people understand. What is this digital infrastructure doing for them? How often do they use it? Do they use it 250 times a day? Do they see the benefits of having this kind of really robust set of tools, digital tools that can do any number of things? Online banking, your cell phone, social media, autonomous driving, automated farming that could produce more food with greater efficiency. I mean, there's so many. I mean, I'm not going to get into all of the downstream benefits.
And that's kind of what I was referring to ultimately. I don't think people understand that side. Like you said, I think there's obviously like the AI taking roles and things like that. And that's obviously a different kind of message. I meant it more from an education piece of like 90% of people probably use this facility daily without knowing. Do you know what I
Yeah,
mean?
yeah,
And I think
yeah. We you know, I see these kind of like, you know, articles about the protesters, right? There's always a lot of
yeah,
protests being kind of organized around some of these locations, and they use Facebook to organize. And you know,
yeah,
it's they're not hypocrites. They have a voice in the community. I'm not saying they shouldn't do this. I'm just saying that maybe it's better if there's like a larger education piece rather than the industry generally somehow getting the message out that we are going to take all your jobs, because I don't think AI
yeah.
is going to do that.
Yeah. And I think that's what I was referring to when I say the education piece onto the
Yeah.
use cases. So, and in terms of, I suppose, how could like 800 VDC architecture change future data centers? What would you say?
That's a very interesting question. The transition to 800 volt DC. A couple smaller things that it's gonna reduce copper by, I've heard estimates up to 60% in a data center, and copper is
Right.
expensive. We're using a lot of
Yeah.
copper. So with 800 volt distribution inside of the data center, we can reduce a lot of that. A lot of the bus bars, cabling, those things get much smaller. Less heat, we're losing less power to heat, which is great, because then you don't have to cool as much, you get better efficiencies. But I think the big driver for this, and this is kind of a need, it's not a want, is the next generation of NVIDIA chips. I mean, the Rubins are gonna drive rack power up to 600 kW a rack. I mean, that's a lot of power, a ton of
Yeah.
power in a single rack. And so the current 415 volt AC distribution architecture just doesn't work. You just can't do it. And so a year and a half, maybe, we're not gonna have a choice. We're gonna have to distribute at 800 volt DC.
Yeah.
You get some other efficiencies as well. Sorry to interrupt, but you get like there's less voltage changes and things that happen from your generation or your utility connection all the way to your PDU.
Yeah. And I think technology, like, is evolving so fast that something that's right today isn't going to be in demand in 18 months. So you kind of have to see where the market is going, like you said, with the chips and things like that. I think that's, like you said, has to evolve into that as a minimum, really, doesn't it?
It does. I mean, this is advanced technology and there's an enormous number of smart people working on how to make this better. And so, I mean, with the most profitable company in history, right, is driving this advancement. So of course they're going to keep coming out with better and better and better, and we just have to keep pace, to catch up.
Yeah. Well, I suppose if you don't and businesses don't, then they're going to become, say, extinct, but they're not going to be, they're not going to win the business, are they? Ultimately, that's just the way of the world. So, yeah, and then kind of the final kind of point in terms of like from future energy technologies, like what do you feel are the most promising within the data center world?
Yeah, so I don't want to advertise for Bloom Energy, but I think they're a great option when you run into permitting challenges, water use challenges,
Yeah.
heavy community pushback. I think they're a great option. Linear generators, of course, it could work in that particular case. But far future, I think is going to be nuclear, SMRs, just because of the power density needed with a data center. I mean, by the time SMRs are commercially available, which nothing has been commercially deployed yet, right?
Yeah.
But by the time they're commercially available, you might have a 10 gigawatt data center campus. I mean, how do you power that? You could have an absolute sea of solar and an enormous number of batteries. I just don't know how realistic that is. So I think that having on-site nuclear power that's safe and clean and emissionless is probably our next step. And there's some changes happening right now, like on the permitting landscape, the president is getting involved and kind of trying to sunset the airline. What is it? It's AIA. It's essentially the protection that went into effect in 2009 as a result of 9/11 to protect nuclear reactors from airplanes, essentially. And so now we have to go through this very long permitting process and this heavy CapEx investment. Those big concrete domes. I think it's 60% of the total CapEx value of a nuclear reactor is the big concrete dome. Is the number that I've heard. A lot. That's a lot of money building concrete domes. And if we can get away with that, or we can underground some of these things and kind of reduce some of those long lead time permitting and design requirements, also those CapEx requirements for building that big dome, then I think the only other problem is the fuel source, right? I think there's like one company that provides SMR fuel sources in the United States, and obviously that's not going to work. But again, these are just growing pains. I think that's the future. I think I had to predict, I think we're 5 years away from like true commercial deployment where you could just go buy one of these things and drop it on site.
I think like I said, a lot of the industry talks about nuclear power, but you're changing, like you said, you're going from an option today, and there's a lot of there's a lot of testing that needs to go into that, and moving away from it. Like you said, we've got to make sure first and foremost it's safe. Like that is got to be the number one priority in anything. But I think that's got to be an option because like you said, like 5-10 years ago, you're talking of a megawatt, 10 megawatt facility, etc., being enormous. Now we're, like you said, gigawatt facilities. I think there's one being commissioned, 7 gigawatt. It won't be long before 10. When I think can't see it slowing down anytime soon.
Yeah, by the time you get to a 10 gigawatt facility with maybe as much as 1.2 megawatt racks, you have to just be generating an enormous amount of electricity. And maybe it's fusion. I mean, fusion is always there. They say it's always 20 years away. So hopefully it's less. Hopefully we can make clean, abundant power. But fission at the moment I think it's a great option.
No, really appreciated your time. Give some obviously everybody wants to solve the power. It's like I said, there's a lot of different bottlenecks in the industry. I think at the moment, for right here, right now, I think that is so I think you've had some amazing input into how maybe we can solve that over the short and medium long term. So I think it's been really insightful.
Well, yeah, great. Thanks for having me on. Again, I love we're all a community here, right? The data center industry. We got a lot to do, a lot of hard work. Putting our heads together, and I think we can solve all these problems. And we're really excited. We're really excited about the future here.